Okay, so, I know that many of you are not super comfortable with the optimization problems, so today is to do those, the textbook problems that we haven't done yet. Hopefully with you and just the person next to you, and that you guys together can fight it out, so that next week, Tuesday, Wednesday, Thursday, I'm not sure yet, so that next week you can do it on your own on a test, okay? So looking at this first problem, we need to read through it and see what we wanna find, so,
So non-negative means positive, correct?
no.
So one can be,
Yeah, what the heck?
one can be zero?
Okay, non-negative, it's very SAT wording. Non-negative means it can include zero. So that is the first catch, is, what's the deal? The sum of two non-negative numbers is 20. So what's our setup? Okay, so A and B are two non-negative numbers. Right away, I know some constraints. Those two numbers, any named, need to be non-negative, and A plus B is equal to 20. Like, were you guys able to read that out of the constraints?
Yeah.
Okay. Unfortunate that we chose A and B, because now we have part A of the question. Okay, so the first question, can anyone give me an equation that's, the sum of their squares is as large as possible, and then also as small as possible?
Okay. What I suggest is, maximum possible value plus zero, which is 20 plus zero squared.
Well, the sum equals A squared plus B squared, right? And the thing we want to maximize is sum. So Millette, I need to get rid of one of the letters. This is single variable calculus. How do I do that?
Would you solve for either A or B?
Okay, which one do you want to get rid of?
Solve for B.
Solve for B. And B squared, what is 20 minus A squared?
Four,
Right, like,
two
Boil it out is what I'm asking you to do.
plus a squared.
It's not 400 minus A squared.
No, 400 minus 2a plus a squared.
Almost. 400 minus
48.
40A. Then plus A squared. Single variable. Sydney, what do I do from here?
You could factor it out, or you can factor the equation
Okay, why do I want to factor things?
to make it easier to solve for.
I haven't done any calculus yet. So Jasper, what do I need to do? I'm looking to maximize and minimize, actually. Now I need to do the derivative. So how is the sum of those squares changing as we change A? Bunch of power rule. So we get A is 10, B is 10. Checking the number line with the derivative.
This is supposed to find a critical point where it changes slope.
Okay, so putting in like 5, get 20 minus 40, that's gonna be negative. and putting in 15, I get something positive. First part of the question asks for where is it maximized? The one critical point I have makes a minimum. What does that mean my answers are for the maximum?
The endpoint.
The endpoints. So 0 and 20, whichever one, choose A or B, doesn't matter, but the two numbers are 0 and 20 that give you that maximum. The 0 squared plus 20 squared is 400. The minimum is 10 and 10, which gives you 200. Yeah.
So like if A and B didn't come out to be equal and you had like, I don't know, like 5 for like B and like 15 for A or something, for the number line, would you only check it with the one that you solved for when solving for the derivative?
Well,
And the critical, or like and the endpoints?
this is the change in S with respect to A, so I would only work with A to determine what's going on. Okay, so that's the answer to the first one. I should write it out, but I'd rather not. So the largest sum possible of the squares, they ask you for the sum or what numbers meet that. So the numbers 0 and 20 make the largest squares possible, which is 400, and the numbers 10 and 10 make it small as possible. All right, this one now, part B. Sophie, this one kind of applies to what you were just asking about. What if one of them's different? So it's the same two numbers that add up to 20, and this time the square root of the other is as large as possible. One number plus the square root of the other. Lily, what would we set up as an equation for that? One number plus the square root of the other.
Just write like A plus root B. Equals sum.
Equals maximum sum, pick a letter. Okay, Camden, suggestion on what to do with this?
Could you like find what B is in terms of like A?
I can find B in terms of A, and I can find A in terms of B. The way I wrote this equation, does it, like, A equals 20 minus B, B equals 20 minus A, which one looks easier to swap out? It's only a small thing, but, all right. If we swap out B, it just looks scary to have. Oops. Wrong way. Did I maximize anything yet? Andy, what do I need to do? Okay. So how is M changing with respect to B? Clara, what's the derivative?
Would be negative 1 plus 1 half times B to the negative 1 half.
So where is that 0? When B is 1/4. Is it plus or minus 1/4? No, Josh, why not?
Restricted to 0.
It's restricted, but I also squared it, so it becomes positive. So B is 1/4. Is that gonna be a maximum or a minimum? How do I find out? Underline. And I am gonna put my constraints on there. Testing, I don't know, 1/8. How do I check that? How about 1/16? Square root of 1/16 is 1/4. 1/4 times 2 is a half, but 1 divided by half is 2. -1 plus 2, it's going to be positive. I'm picking like 10 or 16. -1 plus 1/8, that's negative.
Why do you want to take the positive square root?
First of all, here, from the very beginning, I guess we put the square root in there. But the problem said non-negative numbers. So we get a maximum if the numbers are 1/4 and 19 3/4. We gotta check though, where's the minimum? It matters which one's A and which one's B this time. So is A the 0 or is B the 0 for the other pair? How to check? Are you good morning? This part isn't that hard. All right, how do we know? So the ridiculous thing they're asking us for, the sum of one number plus the square root of the other, it is maximized when the number being added.
Wait, so if B is 1/4, then A is just 19 3/4, right?
Right, so that's when it's maximum.
Yeah.
It also asks for where is it the minimum. I only got one critical point, so it's gotta be endpoints.
It's
So
probably a 20.
who's it? Like, is A 20 or is A?
B 20. Makes B 20. Then A's good.
You guys agree? Already says there's a minimum of this when A is 0 and B is 20. And how did he know?
Because if 20 was A, then it would be 20 plus 0, which is 20, and that's too big.
Right, so basically, check. So Sophie, this one we had two different numbers and it mattered which one was which. Well, if it's 0 plus the square root of 20 or 20 plus the square root of 0, test your endpoints with each of the values, which one gave you the bigger one. There's no like, clearly this is the answer. You gotta check. Okay, scary monsters. Okay, so for the rest of today, I'd like you guys to do the rest of the problems that are on day 44. This is the next one. I have some textbooks around the room. I also have them on the chart. Let's try that problem next. Ethan, I was gonna like pass them around and have one prepared, so can you share yours? Well, we'll go find some other textbooks to spread around. But yeah, I'm gonna ask you guys as a group to put up the work for this minute.
Our answer has to be like.
I guess you could say and then like
We'll get their answer fast.
wait, so like we have to
Divide by one, right?
so like I would get I would set the area like an area and put it into there. But you know what the area is. Oh.
16.
Okay, absolutely.
Okay, 32 over W.
Which one would you say 16 over 8? And then we have to find the.
I don't know how to solve this. Optimizations are.
Does anyone have a setup they can put up for us?
Oh wait, and then did you get something like yes plus or minus? Sorry. Wait. Well, in the constraints. Okay, I got that. I don't know this is right now.
Yeah.
I feel like I did that, and then you plug it in and see it times and then like the line is 0.
Suggestions?
Yeah.
0.
That's like, I found out.
Anyone?
Oh wait,
And then
Oh, wait, no, it's.
Oh.
Did you do
They
the?
got us, yeah.
Oh, yeah.
Okay.
So that's 32 over W.
Okay, guys, suggestion, first thing, maybe just draw your picture. Like, the other one with the numbers, we didn't have a picture, but this one, they're asking about a rectangle. Hadley said she did perimeters 2L plus 2W and areas length times width. Area is fixed at 16. Okay, what now? Like, did you guys get that far? Yeah, okay. Single variable calculus. Which thing am I trying to maximize or minimize, the area or the perimeter? Perimeter, because area is a number we already know. So Fiona, what do we need to do? Correct, it doesn't matter which one, pick one. So Fiona says it doesn't matter which letter you get rid of, but we need to get rid of one of them. We pick W, so using the area formula, we get perimeter is 2. 2L plus 2, not W, but 16 over L. I've not done calculus yet. Miriam, how do I do the calculus now? Okay, yep. Derivatives of perimeter or area. Okay, well, it off. We want to minimize perimeter.
Perimeter.
Okay, what is it?
They were both gonna be negative, so just divide it. Subtracted 2.
Oh, not gonna do quotient rule.
Oh, I didn't subtract, I had to, but.
Guys, please, like, don't do quotient rule on this kind of thing. It's 32 over L. Are they both variable? Just do power rule. Multiply by the power. What's the power on the variable? -1. So multiply by the power and then lower the power and you're done. Those of you that have done quotient rule for this, you're spending a lot of time and potentially making lots of space to make a mistake. Okay, so where is that 0 or undefined? It's undefined. Oh,
Oh, yeah. Just that stuff.
I didn't set up constraints in advance. Length and width need to be greater than 0. And I guess less than 16, no, could be. So I got a critical point of 0 because it's undefined at 0, but I don't care. That's a sad looking L.
Oh wait, because it wouldn't be negative.
At 1 we get a big old negative, and at 10 we get a big old positive. Minimize the perimeter when you make a square. Go figure. You get maximum area in a circle, and the more, like, yeah. And if you had the choice to make it multi-sided, you would end up actually making a circle, not a square, but square, pentagon, regular hexagon, add more sides and you get more area to that perimeter. So the dimensions, it's a 4x4. Okay, so I would like you guys to do the other problems that are, you all have a textbook. It's page 214. We've just done problems 1 and 3. They get fancy. So draw some pictures. Label some things.
Like we already
I think this is
I used to write all my notes and I switched to